All right, hey, what's up, guys? Mr. Fortin here. Now we got to keep adding to our toolkits, our area and volume toolkits. So we're looking at volume and surface area of solids. This should be the second page of, or third page actually, of your toolkits here. And it's getting kind of messy because, guys, we've already talked about prisms. We've already talked about cylinders and added to it the volume formulas here. So maybe we use a different color. We use red for the outside of the volume formulas. Remember, volumes in each of these guys here, take the base area, multiply it by how far up the base goes, right? Multiply it by type. That's going to be the amount of volume you can fit in terms of cubic units in terms of prisms, whether they be oblique or right, or cylinders as well too, okay? Circular cylinder, we know that the area of each cross section is pi r squared. So pi r squared h. There you go, volume of the cylinder here. Okay, surface area we'll do over here. Not much space, but we have surface area. We'll maybe take a little bit here so we at least have it for prisms and surface area. Man, not a lot of space at all here. Surface area of cylinders right over here. We'll just add to it, okay? And the main formula I want to talk about is the cylinders thing. Because if you remember from class today, we just got done doing this, okay? Remember this here. I took you kind of through this and walked you through the net. We laid it all out, okay? We laid it all out. We have a surface area of this, okay? I have a cylinder right here, okay? We got to think about what a cylinder exactly is here, okay? So we're talking circular cylinder in this instance, okay? If I have circular cylinder, then I have a radius right here. Can't really see it. Oh, man. My Sharpie's being rough there. You see little r? Okay, I got a radius of that cylinder, base. Okay, and that's a point, that'll be in our formula. R will definitely be there. And then I also have a height. Okay, you can barely see it, but I tried to draw in the height there. Maybe we'll call that be the height right there. So this is height h. Okay, h. There's my height there, bigger h. You see that? Okay, there's my h. H right there. Okay, so I have r. The kind of defining dimensions of a cylinder, a particular cylinder, and a particular, the defining dimensions of a particular cylinder are its radius of the base and the height of the cylinder. And then we can find out volume really easily. We're going to be able to figure out surface area as well. And we'll add that to our toolkits right now. Okay, let's do that one first, actually, I think. Okay, so with a cylinder, gets a little complicated here. Okay, it gets a little complicated here. So maybe I'll actually do it because I walked you through it, the slides with this here. Okay, I'll leave it on there. Maybe that made sense. And we got to our final result, okay, which was this. And this is what you're going to put onto your toolkits, which is going to be 2 pi r squared plus 2 pi r h. There's your formula. There's your formula right there for the surface area of a circular cylinder. But how do we get there? Let's actually maybe justify it again here too. Reminders on this. Well, this, I have a radius of r. Okay, my Sharpie's working again here. So I can do it. Radius of r right here. Okay, I got a radius of r. So what's my area of this base? Well, my area, okay, if I have this, right, if I have a cylinder, okay, area of this, okay, it's going to be what? Pi r squared, okay? I have one base, I have another base, okay, which is also going to be, remember, if I'm a cylinder or a prism, that I have to have congruent bases that are separated by parallel planes, okay? So this is going to be pi r squared as well. So we know we're going to have that in our surface area, okay? I'm going to have 2 pi r squareds here. 2 pi r squared, and of course the r is the radius of the freaking base, because that's where the circle is here. Because, guys, in between this, right? In between this, we got to find the rest of this here. This is really your question mark, is what this is, and going around to the other side, right? Remember, as we wrap all the way around, and the question is, what exactly is that? What type of a shape is that? Maybe I'll put it down here. I'm stealing space from the pyramids thing right here. And it turns out, okay, I tried to show this in class, try to justify it. Here we go. It turns out it is it's a rectangle. Okay, it's a rectangle. And we know that this rectangle here has the same height. Look, has the same height. It has that attribute in common with the freaking cylinder itself here, that my lateral surface, when I unfurl it, it's going to be a rectangle, and it's going to have a height of h, right? Whatever the height is, whatever our h is of our original cylinder, right? Whatever that height is here, okay? So let me draw my rectangle, which is the lateral surface. Okay, right here, and my height is just going to be h. Look, this is the radius of the base here, radius of base, okay? And what is going to be my width of this rectangle? Well, we talked about in class, it's going to be 2 pi r. Okay, to be 2 pi r. Because what is it in terms of the actual cylinder? Well, if I unfurl the whole thing around the cylinder, go all the way around, I cut it open here, and I go all the way, look, I cut it open here. Go all the way around. Come back around here. Wait for it. Go all the way around. And then my rectangle ends when I'm done going around the circle. How far around have I gone? Well, I've gone around the whole circumference. The whole circumference of the base. That's 2 pi r because it's 2 pi r for the circumference of a circle. Okay, so I've gone around all the way here. So in terms of r, I've gone around 2 pi r times to give me the width of that rectangle right here. So what's the area of this? Okay, area of this equals 2 pi r times by h. Okay, 2 times pi r times by h. So it's the circumference of the base times by the height. That gives you the lateral surface area. Remember, base area and then lateral area. Okay, lateral area are all the either sides or the surface. If it's a cylinder, it'd be a surface connecting the two bases here. Okay, remember solid. Everything filled in between is also part of the solid here. Part of the volume, you're part of the solid here. So we're talking about surface area though. So what I'm gonna do is I'm gonna do plus 2 pi RH. 2 pi RH. There it is. We added it to our toolkits here, okay? Prism for surface areas. Your textbook goes through it a little bit here, okay? I might just give you a formula. When in doubt, okay, right? Just surface area, what I'm going to put here is add up areas of all the polygons that form all faces. Okay, so that's it. That's like, there's not really, there's a fancy formula. It's in your textbook, which I'm going to go over. The textbook formula says, hey, take the perimeter of the base. Let's say that these are my two bases here, okay? Base, and then this is where my height is. I can take the perimeter of my base and multiply it by the height, and that gives me my lateral surface area. So then I just got to add up the two base areas, and that gives me my surface area. So there is kind of a formula. I might put that one down real quick in case you want to do it. Twice times the base area plus the perimeter of the base times by the height of the base. And perimeter is just that's adding up one-dimensional values, so it's a lowercase p in this situation. But anyways, that is a formula that your textbook decides, because they're like, you know what? If you're gonna have to do it, get the areas of surface area of a particular shape. Might as well have a formula for it, huh? Well, that formula is more trouble than it's worth here. Just find this area, double it, you got the other base area. Find that area, double it, you got that base area. Find that area, you got that, double it, get that base area. Add them all up, it gives you the whole surface area. What if you have a hexagonal prism? Well, then you got your two bases, okay? And then you got your six lateral surface areas. Got to find the areas of each one, add them all up. That gives you your surface area. Thank you for watching this video. More videos coming your way soon on some sweet geometry topics. Take care and have a good weekend. Bye.